In this video lesson, we are continuing with the topic of Trigonometry C, and we're going to look at the first of two videos on solving equations using the wave function. In this video, we're going to continue with the topic of Trigonometry C, and we're going to look at the first of two videos, which is on solving equations which involve wave functions. So again, we've done a lot of the prerequisite work for this already, so we'll just go on with example 1. We want to solve 5 cos x plus sin x equal to 2 for x lying between 0 and 360 degrees. Now obviously on the left hand side we can see here that we have the sum of two separate trigonometric functions, and it would be useful to be able to express this as a single trigonometric function. So I can choose the form that I want to do this in, either sine or cos of x plus or minus alpha. So I'm just going to choose k times sine of x plus alpha. And when I expand, that will give me k sine x cos alpha plus k cos x sine alpha. Now equating coefficients then, and we should be experts at this now, we've done it a lot. You can see here that k cos of alpha is equal to 1 and k sine of alpha is equal to 5. So I've got my simultaneous equations. I can now solve for k and then for alpha. So solving for k firstly, I need to square both of the equations, and then I can add them together. So I get k squared times sine squared of alpha plus k squared cos squared of alpha is equal to 25 plus 1. Now I can evaluate the right hand side, but in the left hand side I have a common factor of k squared, and it's useful to remember that sine squared of alpha plus cos squared of alpha is equal to 1. So that leaves me with k squared being equal to 26 and k being equal to root 26. Now I can now solve for alpha. So k sine of alpha over k cos of alpha is equal to 5 over 1. My k's will simplify to 1 here, and sine alpha over cos alpha is equal to tan alpha. So tan alpha is equal to 5, and we just need to check which quadrant my answer will come from. So the equation involving sine is positive, so that's the first or second quadrants. And the equation involving cos is also positive, so that's the first or fourth quadrants. So you can see my answer here for alpha is going to come from the first quadrant. Okay, so inverse tan of 5 is 78.7 degrees, so alpha is equal to 78.7. And I can then express 5 cos x plus sin x in the form k times sine of x plus alpha, and that's root 26 times sine of x plus 78.7. Now, if I look back at my question, remember I've only dealt with the left hand side, I've re-expressed the left hand side, but I was asked to solve an equation, and so far I've not done that. So if we take the question, and we were asked to solve 5 cos x plus sin x equals 2, we can actually change that now to solve root 26 times sine of x plus 78.7 all equal to 2 for x lying between 0 and 360 degrees. So firstly, I'm going to adjust my range here because you can see that x lies between 0 and 360 degrees, but I've got this phase angle involved here. Okay, so the range that I'm going to work with to start with will be 78.7 up to 438.7. So back to my equation then, I'm going to divide throughout by root 26. That gives me sine of x plus 78.7 is equal to 2 over root 26. I can see that this is positive, so in my cast diagram my answers will come from the first and second quadrants. So inverse sine of 2 over root 26 is equal to 23.1 degrees. So you can see in my first quadrant I've got the answer of 23.1. The second quadrant, 180 minus 23.1 is 156.9 degrees. So I have these two answers here for x plus 78.7, but you can see that within this range I will have other answers. So I need to add 360 on to both of these answers to give me 383.1 and 516.9. Now hopefully you can see that the first and fourth answer there that I've got are out with the range for x plus 78.7. Okay, so I'm left with these two answers, 156.9 and 383.1. I can now equation solve for x, so I can subtract 78.7 from both sides of the equation to get x being equal to 78.2 and 304.4. And those are my final answers. I can just check that with a graph. I have drawn here y equals 5 cos x plus sin x, that's in blue, and in green we've got the line y equals 2. And you can see once we've solved that, we've got the x coordinates of the points of intersection. So you can see those answers visually there as well. So just now it would be a good time to pause the video and before the screen goes blank and copy this example down in your notes before trying to solve some equations in degrees which involve wave functions, and then you can come back for the second video to look at solving equations involving wave functions in radians.